this question asks us to draw the alkene that would give this alcohol under acid-catalyzed hydration conditions. What that means is that if what alkene, when reacted with water and sulfuric acid, would provide this alcohol as a product. There are actually two legitimate answers to this question. One would be if we had 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, if we had an alkene between carbon 2 and 3. This would react with H3O+. Markovnikov's rule said we form the most substituted carbocation at this position. Water would then react and form, after deprotonation, our alcohol product. Another legitimate starting material would be if we had the alkene between carbon 1 and carbon 2. This would react with H3O+ to also form the same Markovnikov carbocation. Water would again react. After deprotonation, we'd form the same alcohol product. Now, you might be thinking there's a third one where if we had the alkene between the carbon and the methyl group off of carbon number 2, that could be a third possibility. Actually, it's not. It's just a rotation of this one. It's still the same. If we were to name both of those molecules, they would both be 2-methyl hex 1-ene. And so there's really only two unique alkenes that would give this alcohol upon treatment with acid and water.